and after I built this belt sander for my angle grinder stand, really works great, but I decided that I need something bigger for grinding knives and stuff like that. So I will upgrade to a 2x72 belt grinder. I'm using 0.1 millimeter shim stock for welding to have enough clearance after the shrinking of the weld. So everything is nice and clean, ready to weld. Next step is making the plate for the wheel attachment. I made a little template. So guys, the machine is coming together slowly. The motor mount is ready. I did put a bigger motor on it than I thought I would. So I had to adjust the, the cover a little bit, turn it a little bit in. It's got like 2 mm of clearance now, but still works. So that's all good. But I ran into one problem. When I welded this bracket here, it's a T-joint for the weld. And as you know, for T-joints it really pulls a lot, especially with TIG welding. And I didn't fix the plate as I should have. And I thought it was thick enough, but still it pulled a lot. And now the wheels are not in line anymore. Maybe you can see it on the frame. It's starting to bend right here, and you can see how much it's bent. So now the motor is not in line anymore with the frame, and that's a problem. So we need to fix that, and I'm trying to weld different welds on the other side to pull it back and then grind off the welds. And yeah, so a little problem, but we can find a solution, I think. So let's try that. So the frame is nice and straight again. I ended up welding 3 welds on here, 2 on here and 1 in the middle. After welding, grinding it all off, and yeah, it worked out fine. Plate is nice and straight again. A little bit different way to put it, but for this project it's more than enough. So happy with that. Problem solved, and until the next part. Short talk about the spacer. There's always some tolerance, and if you make it too short, or if you make it shorter, then there's some pre-tension on the bearings. That's not a bad thing if you want high precision, but not too much, of course, and with some pre-tension, but too much will shorten the lifetime or it will run hot. But you also have to keep in mind what is the function. For this I don't need high precision, and I rather choose a little bit too short of a spacer. So maybe it has some side play, just tenth here, talking tenth of a millimeter. Some side play is not a bad thing, and then the bearing will not run hot. The only thing is if you press them in, normally you would press the outside, but now you also have to press on the inside to feel if the bearing is pressed against each other. So that's one thing to keep in mind. So I decided to weld these bridges to get it more solid, but when welding it pulled a little bit on me, so now it's not square anymore. But that's not a big problem. So if it's too long, then you need to shrink this part so you can weld it and then it will shrink back. But in this case it's too short, so I need to lengthen it. So I will do this by hammering it, and that will stretch the material here and will make it square again. So now that the bracket is nice and straight, I mounted the backplate. It's 8mm manganese steel, manganese to give some more wear resistance, but it will wear out a little bit. So yeah, because I didn't want to weld it so I can replace the part, but also just simple things as how you mount it is something to think about, because I drilled the bracket and tapped the plate, so now it's easy. So I can just take it off and rotate the plate so I can use both sides. If I would have drilled the plate and tapped the bracket, then I had to countersink it here, and then I can't rotate it, and it will leave a not so nice flat surface because you have the countersink bolt in here. And now I just put a bolt in, grind it off, nice and flat and easy to rotate. Just 2 holes is strong enough to hold the bracket. So if you use 4 holes, it's always more difficult to get them aligned so you can rotate it. So 2 holes is strong enough and easy to rotate the part. It's a temporary setup with the frequency drive, but it works. So I'm happy with the parts, blackened, a little bit purple, not entirely black, but yeah, for me that's alright. And yeah, nice paint job, I'm happy with that. So let's clean out the threads and then put the machine back together. These adjustable air pressure springs are really nice. You can let out some air to adjust the pressure, and I already adjusted it when I tested the machine. But these are a little bit more expensive than the fixed pressure ones. So if I need to replace this one, I want to know the pressure. So before I will mount it, I put it on a scale. And as you can see, it takes around 40 kilos. For the pressure, so then I know what to order if this one wears out. If you're using fixing bolts like this, it's a good idea to mill in a slot. So if you damage the surface, you will still be able to slide it in and out nicely. And the bolts original have the quite a sharp edge, and this will imprint. So grind that off a little bit, and also grind off the ends of the thread, because if you tighten them too hard, this will widen and then you won't be able to get it out. But if you grind off the edge a little bit, then you will always be able to get the bolt out. This is it, guys. Project is finished. It took me quite some time. I think I started it 8 months ago, but I had a long break in between. But it was real fun to build this one, and I'm also really looking forward to use it. It's nice and strong, nice and solid. It weighs more than 85 kilos, so yeah, that's quite something. The table is nice. I changed I made an extra bracket in between. I was not happy with the force it could hold, with only 2 brackets. So what I did was change the surface area, so milled in a slot and put a bracket in between. So that's really nice, adjustable table. And about the design, I think a few things that I would like to share if you're building one. Maybe it's good to think about. I opened this slot here in the frame. The only reason for that is to keep it clean, because I hate open spaces where grinding dust falls into that you cannot clean really good. So yeah, that's for that. And cut the pivoting point and the center of gravity. So that's really nice. So it's real easy to move from horizontal to vertical. So that's really nice. And the angle plate here has quite some stiffness because it was welded on this spot, so it's welded in an angle. If you make it too large, then it gets floppy, but if you make it too short, then it won't hold enough tension. So just one tightening and yeah, it's not able to move anymore. So that's really nice. And I really like to use only one Allen key for the whole machine. So if I could, then I use the same one for all the bolts. So yeah, I need to use only one. What more? Yeah, these holes are all, the plates are all threaded, but the cap nut is only there for, there for 2 reasons. One, to keep the grinding dust off the threads and not damage the threads, so I will always be able to get it out. And also because it always vibrates a little bit, it's an extra lock, so the bolt won't come out. So yeah, nice and heavy. The center of gravity is also in the center of the plate. Let's see, maybe you can see here. So that's also really nice. I still need to build a moving table for this one, but that will be a future project. Frequency drive is running, but I need to make that inside the card. So yeah, other than that, don't have anything more to say, so let's get grinding. It's getting cold in here, guys, but this one will keep me warm. See you next time. Bye bye.